today's lesson is going to be hopefully on the shorter side. Just about everything that I can cover in the lesson, I already taught you in the warm-ups beforehand. The same thing is going to apply for the next couple of lessons. I've taught you the majority of the stuff in the warm-ups, and you just got to piece things together. Now, this unit, we're working with triangles. And the relationship where we're learning about is Pythagoras. Have you guys heard of Pythagoras before, Chrissy?
Yes.
Oh. You've heard of Pythagoras before?
Yes.
No.
Some people have. Some people haven't. Now, Pythagoras, and it's called Pythagorean theorem, is.
Does it come from Greece?
Yeah, that's where the guy is from.
There it is.
See, I didn't even know that.
Okay, so this chapter is going to be one of the things that you probably remember throughout your adult life. I'll tell you a story. Like, I was crossing the border once, and when you cross the border, they try to assess who you are and make sure you're not lying and stuff like that. So I used to work in Chilliwack, and I used to go to Sumas on my way home just to get gas. And it's a lot cheaper in the U.S. to get gas. At least it was when I was going there. So I go across the border, and the guy's like, Mr. Dolly, well, why are you crossing the border? What are you doing? Or how long have you been gone for? I'm like, 10 minutes. Like, 10 minutes? Yeah. I'm like, just getting gas and be back. He's like, really? And he looks at the time. So what do you do for a living? He goes, oh, I'm a teacher. He's like, what do you teach? And he says, it's like 3 o'clock. It's like, what does this guy do? Right? Is he doing something is he up to some shady? And I'm like, oh, I'm a math teacher. I'm teaching math and science. So the border guard goes to me, the only thing he can remember, I can tell this is the only thing he remembers. It's like, oh, you do that a squared, b squared, c squared thing? And I'm like, yeah, that's what Pythagoras says. You go home and you talk to your parents and you mention, we're not going to learn it today, but we'll learn it tomorrow. A squared plus b squared is equal to c squared. They will remember it.
C squared plus d squared equals e squared.
Right? So what we're learning is how you find different sides of a triangle. Okay, and triangles show up everywhere, and I think it's one of the most actually practical things too. I do woodworking. All right, so every summer I usually have 1 or 2 projects. 2 years ago, I built a patio set for my house, and my patio set looks like, I don't see a decent photo here. This one's not too bad. This is what my patio set looks like. All right. So I wanted to make it nice and comfortable for my family to sit on and occupy my deck. My deck is not huge, but I wanted to maximize the seating. Right. So in order to do that, this is my math involved. So I figured out all these different angles, and I just broke everything down to triangles and dimensions to figure it out. Right. And by grade 10, you'll be able to do this math. At the beginning of my career, when I used to teach Math 9, 12 years ago, we used to do this kind of math in grade 9. Yes, Ethan?
Why didn't you just place the patio furniture? Was all this math really needed?
Yeah, well, have you sat on chairs before and they don't feel comfortable? Right?
These ones.
Like these ones, right? So a lot of chairs are made cheaply. So it's cheap to make a chair that looks like this. It has a 90 degree, right? Because everything crosses at 90 degrees, but they're not comfortable, right? So you want something that has a back recline, right? That's better than this. But you also would, even better than that, you want your back recline and your front recline. That gives you a really comfortable seat to sit on. You think of it like a lazy boy chair, right?
They're like one of those gravity
if you look around, the cheapest chairs you buy will be in this shape. A little bit better ones will have the back reclined. Even better ones will have the back and the leg reclined, right?
Like the, what do you call them, like the gravity chairs?
Yeah, something like that, right? So, and if you talk to your parents, patio furniture is very, very expensive, right? So I enjoy building, so I wanted to create something comfortable. So that's what I did, right? But even if you're not woodworking, but everything is squares and triangles, it comes in handy if you know how to apply the math. All right. Okay. Yeah, so these are, where is it? These are all the little pieces I had to put together. And you can just imagine this. I just broke every little piece of wood into a piece of triangle and a square, figured out the angles and what needs to be comfortable. Okay, so hopefully you guys are going to get there. All right, so we're going to start off with the Pythagorean relationship, and we've already sort of talked about it without using these words. So we're going to introduce the idea. Now this involves products. Do you guys know what the word product means?
It means an answer? Or
No, it means
what makes?
mathematically it means to multiply. All right, that's the word product. If you look it up in the orange up on the board, right, up above the board there, so, right, one of the math terms there means multiply. So the product of a number by itself, so you multiply a number by itself, it's called a square. Okay, so multiplying a number by itself, like say 4 times 4, right, it's called a square, which is equal to 16. Right? So this process, when we multiply a number by itself, we see it's squaring. We're squaring the number. Now, in math, we want to be efficient with our writing, so we don't want to say 4 times 4, because the numbers can be bigger. So we go 4 to an exponent of 2 means 4 times 4, right? That 2 is square. We talked about this a little bit in the past, right? Is that,
So,
yeah, not, right? So if I used a different example, we went 3 times 3 is the same thing as saying 3 squared, and all of this is equal to 9. Because 3 times 3 is 9. Right? Now, the number 3 right here, the base of the exponent, is called the square root. Right? So the other day, when we said, hey, take the square root of number 9, and I showed you how to do the calculator, right? And we found out that was equal to 3. What we're actually asking you to find was, hey, what's this number that would be underneath that exponent? Okay?
Isn't that like the symbol for long division?
Yeah, it sort of is, isn't it? Yeah. Yeah. Okay. Then the other one terminology I want to remind you is of the word prime number. So a prime number is a whole number greater than 1, and it has only 2 factors, 1 and itself. So no other number can divide into it. So our prime factors are like 7, 11, 13, 23. I showed you how to get those off the number line off the board, right? Okay. So let's do some practice here. Let's go over here. So we want to go 8 squared. I want you to refresh yourself with your calculator skills. So you could go 8 times 8 and figure that number out. But I prefer if you can use your calculator using the square button. Right? So
64.
right? So work out what the square of these numbers are. And that'll be part of your assignment today, just like calculator work.
Or
Right?
is this all we're doing? Like, is this
This is the crux of this lesson, right? It just, can you do your calculator? Can you understand the terminology, right? Right? Because if you can't do those, this unit is a wash, right? You won't be able to do much without it. So a lot of the stuff we've done up to this date, you don't need a calculator. In this chapter, you do. And you do need to know how to use it, right? Okay.
So wait, for these bottom ones, are we trying to find the square root?
Yeah, well, let's do these first ones. So we did 64 together. Oh, come on, why aren't you working? Wait, let me see if that will work. 64. So what was 11 squared? What did you guys come up with on your calculator?
121.
121. 15 squared?
225.
225. Okay. So the next thing I want you to do is make sure you can do the square root. Remember how to do that on your calculator? So you're looking for a button that looks like this, the square root symbol. On mine, I have to hit second or shift to get to it. You may have to do that, or you may not. So go through your calculator.
Wait, so 49.
Let's do the square root of it.
Is it like this symbol that has like the dash down, dash up, and then to the side?
Yeah, sort of like that, yeah. So I will write these numbers down
Mine just
and
says
make sure you
SYN tax error.
know how to get it. And if you have troubles with, so square roots and squaring show up in lots of different places. You may have done it already and not even realize. For example, if you had a square, and last year you probably worked with squares, and I asked you to find the area of a square. What's the formula for area of a square? Do you guys remember?
The what for a square?
The area of a square. Yes, Gordon?
Length times its width.
Yeah, so we have a length and we have a width. So area of a square is length times width. Well, in a square, actually the two sides are the same. Right? So we can actually say, instead of length times width, we could just say it's the side squared. It'd be side times side, right? We could just say it's side times side, which is side squared.
Wait, what?
All right? So I just want to show you how you may have come across this in the past.
Oh, I see.
So
Because all-
if I told you the side length of the square was 10, what's the area of the square? Now you could have gone 10 times 10, which you probably did in grade 7, right? But I want you to think of it in terms of exponents right now. So we go 10 squared, which is
100.
100.
So wait, are we basically, because the square doesn't have like any different, like it's all identical. Is that how we're getting the squared part?
Yeah,
Because you can do that with like an uneven square.
no, that'd be called a rectangle. Yes. Okay, so I'm going to skip this part. All right. Tell me what the area of this picture frame would be. Quickly do it. All right. If I told you the side length is 16 centimeters, what would its area be? You've already done it, Dylan? What do we got, Dylan?
256.
So how do you do that?
16 times 16.
16 times 16 or 16 squared. And Dylan says 256. Okay. Now, this question had a measurement. So if we have a measurement, a unit, our final answer should have a unit. So we said the side length is centimeters. What is the units for area?
Centimeters?
Is that what it is? Are we missing something?
Now you're making me.
Oh, you don't remember this from last year? It was centimeters squared, right? Now you can connect this back to,
Wait, but what's the point of having the squared there?
right? The centimeter is a linear measurement. Centimeter squared, you're working in 2 dimensions, and it sort of connects back up to how it came. You came from a centimeter times a centimeter. Now, did you guys do volume last year? No? We're going to do some volume this year, okay? All right, so we'll talk about volume. Volume will have units cubed, centimeters cubed, because we multiply 3 numbers together to get volume. So that's why the units are cubic, okay? All right, so if we're going to skip example 3.
No, I was gonna get the answer for that.
We were done somewhere similar. Go to this second example 3. So if I told you the area of a square is 64, and I asked you, how long is this missing side?
8 centimeters.
Was it Noah who said it first? How did you do that, Noah?
I just did 64 divided by 8, whatever. 8 times 8 is 64.
Yeah. So you knew that 8 times 8 is 64, right? Because Noah knew it was 8 times 8. What if I gave you a different number, right? What if I said the area was 729 centimeters squared? What would you do in that situation? Gordon?
Find the square root.
You just simply take the square root. It's great that you recognize that it was 8 times 8, but you also want to make the connection that, yes, you should take the square root, right? So you take the square root of 729,
And it is 27.
27, right? Or the square root of 64, which is equal to 8. So I want you to know both things, the square root and the fact that it's 8 times 8. All right. So on the next page, I've got a series of numbers here. I've got 24, 25, 45, 59, 64, and 100. I don't know if we'll do all of these. But the question is to you guys, is this number a perfect square? You guys remember us talking about this a couple of days ago?
Yeah.
All right. So the way we check to see if a number is a perfect square is we do its prime tree and see if we have an even number of the factors. For instance, if you take 24, we do its prime tree. What two numbers multiply to make 24?
6 and 4.
6 and 4. And we break this up. 6 is 3 times 2, and 4 is 2 times 2. We've hit all prime numbers, so we can stop breaking this down. So 24 is equal to 2 times 2 times 2 times 3. So we don't have an even number of 2's, and we don't have an even number of 3's. So this is not
Oh,
perfect,
Okay.
right? Square. Right? Right? This is how you prove it, right? If you took 24 in your calculator and you took the square root of it, you would notice that it is a decimal number. So it's not perfect, right? Perfect would have been giving you a whole number. Okay? Let's do the next one. What's 25 break down into?
5 and 5, so it's a perfect number.
Yeah. Right? So this is perfect number, right? Has an even number of pairs. Okay, let's do 45 next. Yes.
5 and 9.
5 and 9, and 9 is
3 and 3.
3 and 3. Those are the end of the line. So we have 45 is 3 times 5.
Not perfect.
Not perfect. We don't have an even number of each. Not perfect. Okay. We're going to skip 59. Okay, 59 is a prime number. I'm not going to put you through that pain. Let's go for 64.
They're both,
Yeah, they're both perfect. You know that 64 is 8 times 8. We did on the other page, but we're going to prove it by doing the prime tree. So Noah said 64 is 8 times 8, right? Then we break the 8 down. 4 times 2, 4 times 2, then, right? So 64 is equal to 1, 2, 3, 4, 5, 6 2's. and it's perfect. Okay, so we'll stop at 64 there. Right, and suppose that, say on the last question there, instead of, I said 729, I'm going to change this to 729, just like we did. We know what the answer is. Is this a perfect square? Yes, we did it on the other side. Now, I'm going to go ad lib here. Is how could you figure out what's the square root of 729? All right, is by doing its prime tree, and I'll show you how. All right, so 729. If a number ends in 9, it's most likely divisible by 9, right? So if I divide 729 by 9, and be 9 times 81, okay? Then I take those numbers and I break it up. 9 is 3 times 3, and 81 is 9 times 9. So go 3 times 3, 3 times 3. Is that okay?
But how are we supposed to know that it's 81?
I give you a big number. In grade 8, I'd give you smaller numbers. I'm not asking you. I just want to show you this, because it sort of shows up in grade 9, then all of a sudden you're really asked to do hard stuff in grade 10, and kids get kind of scared and lost. All right, so 729 is equal to 1, 2, 3, 4, 5, 6 threes. Right? 1, 2, 3, 4, 5, 3, and 6 threes. Okay? Now, the reason why we say, hey, it's a perfect number is if they have an even number of factors. So if you take your factors and you put them into 2 groups, so that would be a group here and a group here, you multiply those 2 numbers out. 3 times 3 times 3. What number is that? 3 times 3 is 9.
27.
27. So this is 27 times 27. Right? By putting them into 2 even groups, your factors, you can find out what the square root of a number is. I'm not going to ask you to do that. But in grade 10, that's where it's leading to you. So maybe in a year and a half from now, and you're going to see these things called radicals. That's what square root symbols are. So you won't be no longer just doing square roots. You'll be doing cube roots and fourth roots. And this is sort of the process you can go into. And maybe, hopefully, one day this will ring a bell. All right? And you have to break it up. Okay, so we'll call it a day there. And so